Welcome to qnawire.
For part A, we can write a Snell's law. That is NA sine theta A, that is equal to NB sine theta B, then we are given theta B is equal to A over 2, capital A over 2. So we can write this Snell's law as sine theta A is equal to NB sine, putting the value of theta B, which is A over 2 here, and then we know theta A is equal to A plus 2 alpha over 2. So this is all over A plus 2 alpha. Then we can plug the value of a theta A here, and then our above equation becomes sine A plus 2 alpha over 2 is equal to, so n and b will write n only, and then this becomes a sine A over 2. At each face of the prism, the angle of deviation alpha is alpha. So for each face, then for two faces, this is 2 alpha is equal to delta. Then we can replace 2 alpha with the delta in above equation. Then we can write equation. The above equation will become sine A plus delta over 2 is equal to n sine A over 2. Hence it is proved that sine A plus delta over 2 is equal to n times sine A over 2. In part B, we are asked to find a delta for the given values of refractive index. Then we can solve for a delta from this equation, and once we solve for the delta, then the equation here we get here is a 2 times sine of inverse into refractive index sine of A over 2 minus A here. So from a given data, then we can plug those values and find the delta here. So the delta will become sine inverse of refractive index is 1.52, and sine of 60 over 2, that is 30, and here we have angle A is 60. Then we can just do the maths and solve. Then the delta we get here is 38.9. This is part B. For part C, for a delta red, so I will write capital R for red. We will do the same procedure, and just we will replace here the n by 1.61, and the angle is same. A is 60 degrees. Everything is same except refractive index n. If I replace in above equation refractive index n by 1.61 and plug this value in above equation here, then the delta red I get here is 47.2. Then for the violet, for the delta violet V, capital V, we will do the same procedure, replacing an N by 1.66 refractive index. If I plug this value up here again in this equation, then the delta V here I get here is 52.2 degrees. Then from here I can find delta of small delta, the angle, the difference of angle between red and violet. Then I can just plug the values here, which is 52. For violet 52.2 minus for red 47.2. So the angle difference I get here is 5 degrees. End of the problem. Thank you.